building an AI for the last 3 years, more specifically the last 9 months, engineering agents in rather sensitive industries like finance or public infrastructure, we could always ask the same question. Is it possible to run any of these super intelligent models locally? We don't want to run them in a hyperscaler setup and we don't want lock-in. The answer so far was always no, until this very day. I think that we are now seeing a new model category, and that's kind of the topic of today's video. I want to bring you on a journey, just explaining a little bit of this incredible release by Google DeepMind in the Gemma 4 model series, what it actually entails for you as an AI builder, and what potential avenues is really going to be opened with this new release. Just to briefly set the stage, what is this all about? We have always had open models. Yes, this was always the case, but there was always a trade-off. So let me quickly just drop down a little bit on the website here on Google. Basically, we've always had a trade-off on intelligence and then on model size, right? So open source was always the case that yes, you will be able to download it, but you still had to somewhat self-host it somewhere on some hyperscaler setup. In other words, you needed very expensive infrastructure to also run these open source models. Yes, you had more degrees of freedom, for example, to then engineer around a Qwen 3.5 or especially also Moonshot Kimike 2.5 thinking, probably the most advanced open source model. But to run these models, you still have to have an infrastructure setup, like for example, an AWS Bedrock setup, where you would then basically self-host the Kimike 2.5 on your products. This had the advantage that if you run it like this versus an Opus 4.6, a Sonnet, or a Haiku model, it was substantially cheaper for all the AI builders out there. Now with this new model release from DeepMind, Gemma 4, a new horizon is opening essentially. So if we just zoom out very briefly on the screen here, the model parameter size has been shrinked. And more on that just in a second, how they more or less did it. Yet the intelligence was kept more or less on par with the advanced frontier open source models. What this now entails that you can technically run more or less locally or with a minimal and not a cloud and hyperscaler setup, very advanced large language models to loop you back into our conversations that we are usually having with again, financial firms or infrastructure firms that are somewhat, again, rather sensitive in what setup they're actually running their AI agents in. This is the first time probably in history that we can now offer in the months and years to come a gateway to actually be running these models locally. As an example, you might have a law firm that has incredibly data sensitive data they would want to be running with their agents. You maybe have even an intelligence, let's say, subsector of public infrastructure that really doesn't want any of the details or any of the documents to be sitting on any cloud setup, even though that is entirely secure, sound, and safe. For example, on AWS, we have something called Nitro Enclaves. Maybe I do a future video on these services. Yet, from a mental standpoint and just a governance and compliance standpoint, these firms or institutions rather, they would want to have some higher degree of freedom how they're actually running the models. And that's exactly why Gemma 4, again by Google DeepMind, is coming into play. And how do they do it? Maybe just a few seconds, just intuitively, how they're more or less probably reach to that. There's two potential scenarios. The first one that I thought intuitively that's how they reached it is in association with a recent article on Google Research called TurboQuant. It's essentially vector quantization that they would kind of compress. It's a typical data compression technique, and that's kind of how they would achieve it. So that was my first intuition when I just saw the drop of the model. But for Gemma 4, what they're actually doing, it's a little of a different approach. That I will link every of these resources in the description as well, from Martin Grudendorst, if I don't butcher the name. So it's essentially a really good guide of how they actually achieved this compression of the large language model. It's not a data compression itself, that they're yielding essentially a much, much smaller model that you can run essentially on a very advanced laptop or one or two NVIDIA graphics cards, and in the future probably even on less expensive infrastructure when the price is coming down of these chips. Nevertheless, let me quickly just very high level and intuitively walk you through what more or less is happening. Really big improvements. They're actually, of course, under the hood, just from a first standpoint, we're actually doing, there is a per layer embedding. So the embedding per se is not being transitioned across all the neural network. They do a token embedding per layer, essentially. That's exactly what is more or less just described here on this article. That's why it's essentially a reduction of the total parameter count they're achieving with this very technique. Maybe just to loop back quickly to the actual use case of these models. Once again, I think the biggest use case is in regard to privacy. So if you're thinking about engineering an agentic AI system that is intended to be running locally, now we have kind of a first shot at a model that is technically capable, both from an intelligence level and also from a price level that you can actually be doing that. So far, once again, you were restricted. You had open source models like Akimi K2.5. You still relied on a public infrastructure to actually deploy and then maintain it. And now more and more advanced AI agents can actually be running, for example, on a desktop of a law firm, on a desktop of a police station, on a desktop of a financial institution. And you essentially in the audience as AI builders, now with the momentum of smaller and more compact models, once again, with token embedding layers, essentially. Now this is possible for inventing new business use cases. The other elements that is kind of the counter argument on this particular progress is agents that can think a lot longer. So yesterday we shot a video as well, maybe we can link it here on the screen, where we walked you through Claude Mythos and how that is opening new gateways for business ideas. And in today's videos, we're going the other direction, smaller models and more compact models that is also allowing you to pivot into new business areas. So essentially, in 1 week, we have 2 new forks on the road on agentic artificial intelligence. One leads to longer lasting multi-agent tasks, again on Mythos, that will be running entirely on public cloud infrastructure. And the other one, a bit the counterpart, is smaller and more dense model that you can also now run on par intelligence, but locally, enabling another array of use case, because ultimately you can also let them run with a particular harness and skills if you engineer that for your customers now locally on site. A good value proposition for many industries. Again, top of the mind is anything from healthcare, public infrastructure, finance, maybe some legal and similar sensitive industries. So that was it for the video. Just a quick update. For me, truly excited that we have kind of 2 different, I would say, announcements in 1 week, opening these new business cases. And with that being said, if you have any question, please drop a comment and see you in the next video. Take care.